I am not throwing away my shot. I am not throwing away my shot. And yo, I'm just like my country. I'm young, scrappy, and hungry, and I'm not throwing away my shot.
All right, here we go. Just like Alexander Hamilton says, not throwing away my shot. This is all we got here. It's our shot to learn in this new setting. So here's the background. This is Bowman's IM3 online learning series. I'm gonna try to keep everything pretty consistent. So this is what it's gonna look like, kind of the home screen. If you notice down here at the bottom where it says key characteristics of a function, that's gonna be whatever unit we're working on. That'll be the major kind of unit. Then over here will be the lesson where it says inequality and interval notation. So the unit first, followed by the specific lesson. All right. Next, again, the unit, I'm going to show you kind of the major theme, the major goals you're going to be learning in that unit. So, for instance, here, we got inequalities and interval notation. That's this lesson we're doing. It's lesson number 1. Then we'll do domain and range. Then we'll do in behavior. Then we'll do extremas. Then we'll do intervals of increasing and decreasing, and then intervals of positive and negative. Those are the major characteristics of a graph, of a function that we will talk our way through, and that's really kind of your first unit. All right, so let's jump forward to, and then in every lesson, you'll have the goal of that specific lesson. So at the end of the day today, over this very short video, you should be able to take any type of numerical value from a graph, from a number line, and write it as an inequality, and also write it using interval notation. All right. A few kind of just digital learning reminders here. As you're going through this video, you're going to need to take your own notes. So you're going to have your notepad beside you. You're going to have your paper and pencil beside you, and just label it. I would label it whatever the lesson is, and then write down. They're basically just a bunch of examples. So draw the number line, draw the answer. And if you need to pause the video, you just pause it. And that's the cool thing about if you're in class and you get behind and you get frustrated and you have to raise your hand, can you re-say something again? Guys, you got that at your disposal. You can write it, pause it, replay it. So here we go. Lesson number 1, inequalities and interval notation. First, let's look at inequalities first. Basic, guys. This goes back to Algebra 1, which I taught most of you back when we were in Integrated Math 1. So here we go. What this tells me, with the open circle, okay, with the open circle right here, so if I had my pen, get my pen ready, so if I want to write for you, you have an open circle right here, which means, you guys know that an open circle means that that negative 1 value is not included in this numeric values. So, tells me here that what could x be then? Well, x could be anything that is less than negative 1. It can't be equal to, so we don't have an equal to symbol under here. It can only be less than. Now, the question that I want to ask you, how far does this arrow right here shows me that I'm going how far? How far to the left do you go? And do you go to negative 100? Do you go to negative 400? What does that mean? Well, it means that you go to negative infinity. It's a very bad infinity symbol, but that arrow continuing tells me I'm traveling to as negative infinity. So x is less than negative 1. We could also write it like this. Negative infinity is less than x, which is less than negative 1. And so that's showing you negative infinity is the farthest you can go that direction. Now, can you ever arrive at infinity? No. So this will never be an equal to symbol when you talk in reference to infinity. We could arrive at negative 1, and so if this were a closed circle, that would be equal to. But since it is not a closed circle, it's not equal to. So, basics for inequalities right there. All right, next one. It says, this is my closed circle at 4. So now 4 is included in that value. So it could be 4 and everything smaller than 4. So again, we're paying attention to it arrives at 4 and 4 is included, and then it's everything to the left. We agreed, how far does this thing go? Well, it goes all the way to negative infinity. So our our symbol down here, x is less than or equal to -4. That means anything less than or equal to -4 is part of our values. You could also see it like this. I'm going to negative infinity. Do we arrive at negative infinity? If you're sitting by yourself watching this, you should have said no out loud. So it's never going to be equal to, so that's x, which is less than or equal to 4. And that tells you that x is somewhere between negative infinity and 4 being included. Okay? All right. Now we changed the way it looks this time. Now I've arrived at -10. So that means from -10, right here, it's equal to, I'm included there. This arrow now is going to which direction? It's going to the positive round. So do I go to positive 100, positive 300? No, I go to positive infinity. Okay, looks like a snowman sideways. I'm going to go to positive infinity now. So now what this thing would look like, my smaller number is always going to be the left. So now I'm at, if I'm bigger than -10 or equal to, that means my smallest is -10, and it's equal to x, less than or equal to infinity. Say, whoa, whoa, Bowman, check yourself. You said you can never arrive at infinity. You're right, so therefore infinity is never equal to. Okay, you will see it written like this. You also see it written with just the single one. But x will always be in between. Your left side is always your small number, and your right number is always your larger number when you write it as a combined inequality like that. Okay? All right, now let's look at one here. Here, your values travel only from -7 to 3. So therefore, I'm at -7 and I'm at 3. It's everything in between, but it does not include those values. So here we are, everything in between. See, open circle, open circle. I'm everything in between these two values, but they're not included, which is where this inequality comes from. All right? Make sure you're writing these notes down if you need to be. Start your notebook. All right. Now, we jump into inequalities that have something else going on, and this symbol right here in the middle, okay, is known as the union symbol. Okay, union symbol. That means that's basically another way of saying mathematically and, also, as well as. So if you'll notice, your green line here, -7 is included, and it's all the way to negative infinity. So from negative infinity, we don't arrive at negative infinity, so it's not equal to x less than or equal to -7. All of those are part of the solution. The union symbol here also, and 0 and above. So 0 is my small number. I've arrived at it, so it's less than or equal to x. And what do I go to over here? What's the far end of this side? Positive infinity, negative infinity. So now I go all the way to positive infinity. But this union symbol right here tells us this as well as this. That's how you tell the reader it's also this as well. Okay? And that segues us into interval notation, which is what you're going to see primarily when we start dealing with these key characteristics and how do we articulate to the reader. You're going to see these in interval notation, which makes so much more sense. So here we go. This is recapping the ones we've already talked about, so not inequality anymore. Now, how far do these values go? Well, if I go all the way to the left right here, I'm going to make it to negative infinity. That's where this comes from. Okay? How far do I go to the right? Well, I go all the way to -1. Okay, you say, Bowen, okay, well, so let's put those in parentheses. That's that easy. Yes, it is. But here's a different level of notation. Interval notation are either going to be in parentheses or they're going to be, whoops, I ran out of room, or they're going to be in brackets. Okay? This is basically not equal to is when you use parentheses, and then the brackets is when it is equal to. So if you'll notice up here, do I ever arrive at infinity? No, you never get there. So it will always have a parenthesis if you're dealing with infinities. -1. I don't quite arrive at -1. It's not included in those values. So again, it is a parenthesis. Okay, brackets if it's equal to, parentheses if it's not equal to. All right, keeping on with the same idea here. The values, I'm going to -infinity this way. Do I ever arrive at -infinity? No, thus the parenthesis. But I'm at -infinity all the way to 4, which is included. Denote right here the bracket. So this tells me -infinity is not included, but 4 is. I arrive at 4. That's a part of my numeric values that represent this section. Okay, super simple. Hope you see that there. All right, next one. -10. See how it's, again, the small number. -10 is included because there's a closed circle there. It's an endpoint. It stops. But then I travel all the way to positive infinity. Well, I've already stated to you, you don't arrive at infinity. So what is this numeric value? It's from -10 included, which is why there's a bracket, to infinity, parenthesis, because you don't arrive at infinity. All right. Now, this, I have 2 endpoints on each end. You don't have arrows that tell you it's going on and on and on and on forever. You have endpoints. Therefore, -7, okay, to 3. And we just notice it's everything in between those endpoints. However, is -7 included? To which you would have said no. Is 3 included? No. Therefore, 2 parentheses, and this is interval notation. You're telling me, the reader, that when we start talking about domain or what section is increasing, which section is decreasing, what section is positive, what section is negative, you're going to say on the interval -7 to 3, such and such things are happening. This is what that notation looks like. Parentheses because it's not included. So let's say these were closed-in dots. Still between -7 and 3, except for this time, my endpoints would be included, so I would use the bracket. Okay, hopefully that makes sense to you. All right, here's where the union comes in. Same thing this time, except for we have 2 sections that represent our values. All the way over here at -infinity, all the way to -7 right here is included. So, -infinity, we don't arrive there, so it's a parenthesis. We arrived at 7. Are we finished? No, because we also have this section right here all the way to positive infinity. So, do we have more? Yes, we do. That's why we use the union symbol, because there are more values. Guys, you might have 3 or 4 sections to where you had an interval right here, union, with another interval right here, union, with another interval. I mean, you might have several of these sections that are all positive or that are all negative. So the union just says, but wait, there's more. All right. And again, 0 was included, so we had a bracket, but infinity was not, because again, I've said it 50 times already, I feel like in this gig, infinity you don't arrive at, you don't arrive there, so it's not equal to. All right. And that concludes. So that is the video for inequalities and interval notation. Okay, so that's it. Good luck. The assignment that is in Kittim that will follow this, you'll just go there and knock that out.